This, this crossover distortion is happening primarily because of your transistors. You know that in a class B amplifier, I'm going to use two transistors, right? So each transistor, I am feeding the input to the base junction. And you have a base emitter junction here. You have a base emitter junction here. And you know this base emitter junction will start functioning only after the cut-in voltage. Cut-in voltage, it is zero point 0.3 for germanium and it is zero point 0.7 for silicon, right? So as long as the input signal is less than this cut-in voltage, the transistor will not work. So it will work only after zero point 0.7 volt for silicon and zero point 0.3 volt for germanium. So till then, the transistors will not work. So the distortion happening because of this phenomenon is called as crossover distortion. See here, this is caused by the non-linearity of the input characteristics of transistors. Transistors do not turn on at 0 volt. If you apply any voltage to the base emitter junction, immediately transistors will not turn on. They will turn on only when the emitter base junction voltage is more than V gamma. V gamma is called as cut-in voltage. Cut-in voltage value is zero point 0.3 volt for germanium and is zero point 0.7 volt for silicon. Unless the value is less than zero point 0.3 or zero point 0.7, the transistor will not conduct. So you can see at this point till the cut-in voltage, the value is zero. The current is zero. Only after that, the current is rising exponentially, right? So if you apply a input sinusoidal signal to your base, the output signal will look like this. So 0 to 0.7, the value will be 0. And then it will start increasing. And when the input again reaches below 0.7, it will become 0. So this is a proper sine wave. But here you see some portion of the sine wave has the value as 0. Here only one value of sine wave is 0. But here multiple values are zeros. And this waveform and this waveform are not same. They are different, right? So this is called as crossover distortion. Crossover distortion happens when your transistor is not conducting immediately at 0. And that is the property of transistor, because transistor will conduct only after the cut-in voltage is crossed. Okay, only after the cut-in voltage is crossed, the transistor will conduct. So if you apply a sinusoidal signal at the base of your transistor, the output is not a proper sinusoidal signal. I hope you understand what I say. Okay, so see here, I'll just draw it even. So this is 0 and 0.7 is somewhere here. Assume this is 0.7, 0.7. So usually sine wave will increase as you increase as the time is varying, the sine wave will, so it will increase and it will reach the maximum. This is the ideal case. But what happens in the practical transistor, till 0.7, the sinusoidal signal will not conduct. So it will increase only from 0.7 and you will get this portion of sine wave. This portion will not be there. Since the input I have a proper sine wave, in the output this portion of sine wave is cut off. It is called as distortion. Similarly, here also it will kind of stop whenever the signal reaches exactly equal to 0.7. So you will not get an exact sine wave at the output, and the difference is called as distortion. Okay, the distortion is caused because of non-linear characteristics of your transistor. Transistor is non-linear because it has some harmonic distortion, it has some crossover distortion. The reason for crossover distortion is mainly because of cut-in voltage that is represented by V gamma. And V gamma is 0.3 volt for germanium. It is 0.7 volt for silicon. Yesterday, even when doing lab also, Zener diode, you might have seen that it will conduct only after 0.7, right? Till 0.7, we found the current to be 0. After 0.7, the current was increasing enormously, but the voltage was remaining constant. The concept here also. Okay, this characteristics is drawn and the output is shown. You can see this is the output. See, this is the proper sine wave, but here you see the sine wave is not looking like a proper sine wave. It is having lot of zero values in between. So this is called as your crossover distortion.